Perfekt.
Kolla, titta.
Åh gud.
Är vi live? Härligt! Och ledsen till alla er där ute som har fått vänta i mörker i 10 minuter. Om ni är kvar nu så extra tack till er. Och tack alla ni som är här idag. Jättekul! Vi ska prata om dataanalys och om analys av rörelsedata. Och det här gör vi ju dels naturligtvis för att vi tycker det är vansinnigt kul med dataanalys. Men även för att kanske lämna med någonting till er på förhoppningsvis era dataresor. Ta med er och fundera och kanske få hjälp av. Vi som är här idag är Björn Thalén, Data Scientist. Ni kommer att höra mer från honom. Och Robert, samma sak, Data Scientist. Och jag, Christian Örten, som är partner på en av grundarna i Indes.
Christian, engelska.
And then suddenly we switch to English. And I'm sure you will get some more of our introductions later. So, today, to shortly recap, I hope you will get an inspirational journey today with us. And we'll talk about 3 things. First of all, we'll present ourselves. Who is B3 Indes? These guys standing up here talking about data analysis. And then we will actually talk about data analysis on this movement data. And then not only analysis, but practical examples where data is put into value. So that we will hear more from Björn. And who is B3 Indes? First of all, we can explain part of the name, B3. It comes from being part of a large corporation, a consulting company called B3 Consulting Group, with over 700 employees. And we were founded basically 2 years ago. We have now reached 20 employees. This is a hot area to be in. It's not only fun and inspiring, it's also very hot. And why did we start this company? We sat, Casper, my co-founder, who is here, and I, we sat and discussed different companies to start, and we said, data and analytics, it's happening so much. We can see how business intelligence and artificial intelligence are merging. We can see that there is loads and loads and loads of more data than previously been possible to access. IoT, we have all the APIs for everything. We have the processing power, the AI algorithm, and we also can see RPA, robotic process automation, merging into these areas. We said we cannot not start a company in this area, then we are stupid. We might be stupid anyway. We couldn't resist. So what do? We do exactly that. We do data science, we do business intelligence, we do RPA, we do forecasting, optimizations. We also work with the businesses to actually become data-driven. And I thought we need to eat our own medicine. So I took this long, really complex description about what we are doing. And then I went into one of the world's most advanced AI called GPT-3. It's one of Elon Musk's company. And I entered this long text. What do we do? Can you simplify what we do? Yeah, it could. B3 Indes help companies make money with data. Okay, it's that simple. That's what we do. So let's talk about the other part of B3 Indes, the Indes name. And that we have to blame Casper for this. He is advanced fencing pro. And Indes is a fencing term, and it means that you should be so well prepared. So when new information comes in, now in terms of an attacker or something, doing something with a sword, but when that new information comes in, you should not only be able to react, but you should also be able to act. And that is what we want to give our clients and the partners we work with. So, enough about B3 Indes. You get the picture. Now let's talk about some of the interesting stuff. And suddenly I hear my voice. Maybe I was quiet before.
Yeah, so for interesting stuff, we switch over to me, of course. because data analytics is the topic I think is most interesting to talk about. The topic I think second most interesting to talk about is about myself. But I think you're mostly here for the first part, so I will just mention a few words. My background is data science and mathematics. I worked a long time for the airline industry, and today I'm working both with Volvo and with Västtrafik as part of between us, sort of helping people in their data journey. And what we did for this presentation is we took a couple of hundred of millions of data points from 2 different data sources, and we put our brains together, and we used some really hard computing power, and we discovered that during Corona, people are traveling less. This might not come as a big surprise to most of you, but sometimes the insights are that easy. So the data we're using is 2 parts, and we're talking first about the first part here, where we're using movement data from Telia. This is a very large data set. It's about, I think it was about 72 gigabyte data that we selected to do our analysis on. It's been automatically collected from mobile cell towers, so they can see how people move. It is, however, an important note also that this is GDPR compliant. We are not looking at any personal data here. We are just looking at how many devices are moving to and from places. And we selected, since we are in Gothenburg, we selected to look at Gothenburg and the surrounding area. The period we've been looking at is from 2019, September, because we want to have some data before Corona hit, or before the restrictions set in, and up until October this year. And as I said, Telia has landed this data for this presentation. If you hear this presentation and feel, oh, I want to do something with that data, we're happy to put you in connection with Telia directly. So my conclusion was that we travel less. And then for the more deep dive insights, I will hand over to my colleague here, Robert, that will take you on the first part of this story.
Actually, I don't need that one. I have a mic.
Cool.
Yeah. So my name is Robert. I work as a data scientist at Västtrafik. I will hopefully guide you through this movement data. So what you can see here is a graph of all the trips that have been done during the Gothenburg area from 2019 and onwards. And as you can see, there's a dramatic decline around March 15 or 16. And what happened 16 is that the recommendations for working from home were implemented. So you could draw a connection there, and it's not that surprising actually. So we will move on from there. We have been looking through trips into Gothenburg from the surrounding areas, and the surrounding areas are marked in green and into Gothenburg. And the reason for that is that we want to answer the question: are we avoiding the city, which is kind of something of our hypothesis, at least. And it turns out we are. You can see the weekdays as a gray lines, and on weekdays we travel less when Corona hits. On the weekends we also travel less, and in general we travel less on weekends also. What's interesting here is that Sundays are less before Corona. Saturdays are a little bit higher, but when Corona hits, they tend to be almost the same. So one reason for that could be that with restrictions and implemented regulations, maybe Saturdays become a bit like Sundays. There are no events, there are no bars open until very late, and people are traveling in the same way. That's maybe a conclusion to draw from that. And we can also take a look at the comparison between weekdays and weekends directly. And you can see that the patterns follows almost, they're very, very linked. So you see here it's the same, these are the same travels, but for weekday and weekend, and they follow very, very closely together. And what that may tell us is that it's not only restrictions on work or recommendations to work from home, it's not only commuters that are not traveling. It's actually when we are giving the choice to not travel for weekends and other events, we are not. So yeah, that's kind of interesting, I think. We can also say that the traveling went down equally from all areas. So what you see here to the left is before Corona, and the areas are very, very similar to the graph to the right, where you see during Corona. There is very, very little difference. We had expected there to be, our hypothesis here was that the further you go away from the Gothenburg center area, the less, or the more likely you were to follow the restrictions because of the proximity. But turns out that was not the case. So debunked. So let's take an example of traveling. Here's a graph for all the travels again. And if you take a look at the rings I've made here, there are actually sharp drops here, two very, very sharp drops. And they coincide with the New Year's weekend or the Christmas weekend. So for 2019 and 2020, not that surprising, maybe people travel less during the Christmas, but actually they travel 25%, even 25% less compared to before Corona and during Corona. Interesting statistic. So what can we do with this? Turns out not actually a lot. So the reason why I want to show you this is because this is a statistic that I drew. I'll tell you it's interesting because it's something that happens and it's 25% less. Wow. But from a business perspective, what we should be asking ourselves is, can we use this information to make any improvements? And if we can make those improvements, what do we need to do to make those improvements? And if we get that far, we can ask ourselves, are we doing anything now to make those improvements? And then we can go very, very deep into that, of course. But so I would just say that this is kind of a data scientist trap, where we look at something very, very interesting, and we feel that this is very interesting. But from a business perspective, there's also a big thing missing here. And it's not uninteresting, it's just that something is missing. So I want you to keep that in mind. So we can also take a look at where we traveled to during Corona inside Gothenburg. Not surprisingly, again, you can see that Brunnsparken and Centralstationen went down. We did not travel through the center as much. One conclusion to draw from that could be that we are not traveling collectively that much, especially from Centralstationen. Maybe we're not traveling by train. Some places are staying the same, like the Bäckenboll Köpcentrum and the Stora Åvägen. And Stora Åvägen, for those who are not from Gothenburg or don't know where that is Sisjön. So I guess maybe you are seeing where I'm going with that, that we are actually not avoiding shopping centers, at least when we can go there by car. So one conclusion that could be drawn from that, maybe, is that maybe we felt safer going by car than not going by car. And that's why those populations are virtually the same. Then what's also very interesting is that some places actually are more populated during Corona than before. And to the right, you can see Spåntorget. It's been increasing, so I will go into that a little bit more and talk about that a little bit. Spåntorget, the counter trend. Wow, it's going up. We have an increase in population during Spåntorget, even though the general traveling went down, which you can see in the below graph here. So maybe this is where I should place my restaurant that I'm opening. Maybe this is where I should invest in apartments or other type of things that I might want to do. This is where I should do it, apparently. This is another way to look at it. Actually, we can take you can see that the higher you get here, the more number of trips you have to this place, and to the right is the percentile increase compared to before Corona. So if you are to the right, you get more trips. If you are to the left, you get less trips. And here we also see that Sponsorit stands out, so it might be an interesting point to look at. So why? Why is it like that? We could deeper into the data maybe. We can do a bit more research. Might make sense. But a good guess is that it's not Sponsorit itself that has the pull. There's a hint. And if you're not going to the beach at Delsjöområdet, then maybe there's a lot of track areas and a lot of tracks and biking areas and things like that. So a good guess here is that people are moving outside in the woods and they go through Sponsorit. Interesting. Hint. So what did we learn? We learned that travel went down by at least almost 20%. The weekend was the same. We travel less on weekends as well as weekdays. It went down from all areas. We do not, in general, travel less from any area than the other. And actually, some areas are very, very popular. Some areas stay the same. Yeah. So, what is the value in those learnings? Do you have the answer to that, Björn?
No.
You don't?
But I will talk about it anyway. So, I think my main answer to is what is the value to those learnings is that it's not that much. And the problem here, as we talked about, there was something missing here. What was the purpose of this? Because even if there are very interesting insights, in a commercial perspective or a business perspective, those insights in itself doesn't give you any actionable things to do. You can't see that actionable value there. But then you might ask yourself, so what was the purpose of doing this? And we actually had several purposes of doing this exploratory data analysis. But I want to reconnect a bit there. Because when you hear exploratory data analysis, you think that, okay, so you have some data, and you do this really fun thing in the beginning when you just explore it. You don't know where it will take you. And I think my point here is that even in that stage, it's important to have a purpose. If you have no idea what you're exploring or where you're going, there is usually lots of traps to get into, and it's rare to actually find this real value. So even in the exploratory data phase, you need to have a purpose. And we did have a purpose, actually. But the questions you need to ask yourselves is, why are we doing the analysis? And even more important, what action are we hoping it will lead to? So then you ask yourselves, okay, so what was the purpose of this particular analysis? If I just said that the value was not that much. Yeah, the purpose was mainly to make an interesting presentation for GB Tech Week. And I hope you are doing that. I hope you're finding some non-trivial patterns that can give you some insights, some aha feeling. And then the third thing here that is at least important is to show just an example of things that can be done with type of data. But if you're only taking away one thing from this, I think it's more important to take away this thing that it's important to have purpose through whole your data journey and have a clear intention. But if we're going to speculate a bit, okay, so what kind of real value could you get from this same data set that we're looking at? The first thing here would be some sort of event analysis. That has been quite tricky to do during Corona because there was no events. But hopefully that will start up again. And then the question is, okay, so who can have value from that? Well, one obvious value is from the Gothenburg city, how they should evaluate different events. But then it's not enough to look at how many people went there, how many bought a ticket to Scandinavium. Because the most value for a city is when people travel from outside Gothenburg. So then you can look at, okay, so how many people traveled here? And also, how long did they stay? Did they stay over at the hotel? Or did they just go home again? And where did they come from? And which event brings in which kind of people? Another thing that we actually touched on a bit is you can try to find underutilized commercial areas. Well, that mean that if you're, for example, starting up a business and you have something that is sort of very public-centric, you're going to sell hot dogs or a coffee shop, it might be interesting to see, okay, where are people? Where are the areas where there are a lot of people hanging around or traveling to that does not have these services today? It could also be if you're a big chain and you want to think, okay, where should I put my next expansion? Then this data could also be very interesting. But then, of course, you need to have the perf before you start looking into that. You need to know what you're looking for, and then I think this data set can help a lot. Coming back to events, there are another kind of events that are much more low-key. And for example, this around Delsjön, when people go hiking in Delsjön, they don't buy a ticket. Or at least I don't think they do. I didn't do that. Hope you shouldn't do it. But then we can still, with this telephone data, see, okay, so there are a lot of people moving there. And again, this could be, for example, very valuable for the Gothenburg city when they want to, if I'm a politician, want to say, okay, I want to spend money on this area, or I want to keep this nature reserve. Then I can actually show hard fact that people are using it. Or in the case that we have some areas that people are not using, maybe trying to figure out why. Why are people not traveling there in this really nice area? And that you can never get from like a ticket sales, because there are no ticket, but you could get this from this data set. And on the same sort of topic, but looking at hours instead. Say I have a business, I'm selling hot dogs. And I probably know pretty much how much I'm selling when I'm open, or at least I should be knowing that. If I have a good BI system, I know exactly how much I'm selling. But I don't know how much I'm missing out on. So, for example, if I say that I close at 10 p.m., and I have seen that from 9 p.m. I don't almost sell anything, then the conclusion might be, okay, so I can close at 9 p.m. I will not lose as much. And that is a valid conclusion. But another conclusion can be that if I look at the data, I can see that people are still hanging around there. And there's a lot of spike here at 2 a.m. when the bars close. So maybe I should not actually close earlier, I should close later, because then I can catch all that business as well. Because you don't have no idea how much you could be selling on the hours you're not open. And experimenting that is one way. Looking at data to know what to experiment with, I think, is a better way. Okay, so now we've been talking about some cool things we have done. We have talked about some stuff that could potentially bring value. And then you might be asking yourselves, okay, so are you not going to show me something you've done that actually has value? And yes, we are. But I will wait a bit with that. Because first I think we need to reiterate this most important message. How do we do it? How do you create value from data? And maybe do you have an idea there, Christian?
Maybe. First of all, the first insight is that getting value out of data it's really, really complex. You need a lot of skill sets. It's not enough with being able to crunch data in Excel or with some data scientist tool. You need to understand the effect you wish to have, and in order to do that, you need business understanding. And you can then start to think about what kind of analysis you want to do and what you want to do with that analysis. And that needs creativity. A lot of creativity, because you can do it in so many ways. Some are really dumb and some are really smart, and the smart ones are hard to figure out. And of course, when you get the insights, you need to act on them, and finally you get value. So if this now is so complex, it's hard to get stuck in complexity. That's why we advocate simplicity. This illustration is trying to show that a visualization of data, it's the bridge between an iceberg of data and then the business. So the visualization should be done in such a way that it requires the least possible energy from a viewer to go from data to insight to actually understand what they will do with it. So having a dashboard with 43 different diagrams, it will require a lot of energy from a user to figure out what am I supposed to understand, and later what am I supposed to do when I've understood something. So spend energy in making it simple. What is the data that you only need, the analysis that you only need to make the desired effect? This one I wish you bring with you from here. The other one is to say that you need to act on data, right? If you don't act, you don't get any value. And I don't think I've met anyone that doesn't agree with that. But I've met many people that actually does not act on data anyway. And why is that? Because acting on data is complex. What you do when you identify the 3% of unprofitable customers, what is your action? It's probably not an obvious one. Do you stop having them as customers? Do you change the product mix? Do you do something else? Do you raise prices? It's complex. But if you start to view an insight as a process, something happens, because then you start to realize that, okay, this act on data, it might not be as simple. It might need several persons to do different things, maybe in several departments. And when you give it that attention, an insight is a process trigger, then you will probably spend the energy needed to get the process going, and you will reach value. It's the most destroyed word, value. I really don't like it, but I can't stop using it because it's so significant. I mean, you make money, you save time, you make things better in some way. So let's stick with value and time. So insight is a process trigger. So then when you start your journey towards being data-driven, if you're on it, what are some general advice we could give? First of all, being data-driven, it's a mindset. It's when you go to work and ask yourself, how can I use data to improve my work or improve my company or make life easier? That's the most attractive one. You need to be curious, and you need to constantly ask yourself. I spoke to Ati Sagami, he was the head of AI for Hennes Mauritz, and he said that, Christian, you can't do these big, complex things that no one understands. You need to do many small things in many places. And look what has happened in that company. So that is a fantastic advice. Another thing to consider is act on the data that you already have. I spoke to a guy who said that, oh, can't you come in and do, some AI stuff and give us some dashboards and stuff? We really need that, I think. Okay, I said, so do you have any KPIs in the management group that you kind of go through each week? Yeah, we do. Okay. Do you do anything about them? Do you act on them? Or do you just talk about them? Yeah, we actually don't even talk about them. We just look at them, and then we go on with other stuff. Okay, first step, start to act on the data that you already have. What can you do with this information? Take small steps, do something to get this mindset going. Lots of small steps I've mentioned, so we stop that. Encourage people who is actually working with data. Another company, they said that this guy in the UK is actually doing A/B testing, and he is trying different prices for different customer segments, and he's measuring how this works. Encourage such initiatives. Make them public in your company. Create more of that behavior. And then keep it simple. What does that mean? Does it mean do simple analysis? No, not at all. It can be really complex analysis that are needed. But you need to communicate it in a way so people understand. If they don't understand, they can't see the value, and nothing will happen. Finally, this is change. Being data-driven or acting on data, it requires energy. Anything requires change, requires invested energy. So be prepared and decide to invest your energy, your personal energy, in this from start, so you don't get exhausted. We can learn a little bit from innovation on how to select what to use data for. First step in innovation is that or successful innovation, it can be done in many different ways, but successful innovation typically starts with that you identify a problem, not that you start with, I have an idea about whatever. You start with identifying a problem. Then you validate that this is really a problem, or is it something you think is a problem? So when it's really a problem, you can ask yourself, what would it mean if we solved this problem? Money, time, quantify it. Same thing with data. Okay, what do we have a problem that could potentially be solved with data? Yeah, we have that. If we have that insight, what would it mean? So we don't get derailed in doing some analysis that don't really matter. Then you come with an idea, oh, I have this product that would solve this problem. I can make this analysis and this following action that will solve it. To how efficient would it be to solve the full problem? Secondly, try it out, start acting on it. Not that complicated. And then keep in mind that value comes before perfect. Do you understand what that means? It's so easy to get stuck on doing the perfect analysis or making it comprehensive. So you have everything covered. You can actually start creating value much earlier than that. It's just practical thinking. Value comes before perfect. The last thing I want to leave with you is how we have organized the role in our company, because this can apply to any company as a template for the roles you need to have. Typically, the obvious thing is the central here. You have people that create business intelligence or artificial intelligence solutions, and then you stop. You need data engineers to provide the data, and that is probably something you will discover. But we have also added 2 additional roles on the side. First, to the left, the business translators. Their jobs are not to gather all the requirements. Their job is to understand the business, understand the desired effect, and understand what data is the only data needed to make the desired change. So it's rather about restricting the number of data points you have. On the right side, it's patience, business executors. Those are the guys that will actually take the organization through acting when you have reached an insight, what you need to do, gather the required people. Down below, I said that RPA is merging with AI and BI, and that means that you can probably automate a lot of these processes where you execute on the insights. And you can even, to the left here, automate the analysis itself, making life a lot simpler. So I think we will see a lot more of this. Finally, in the top, of course, you need the data scientists that can act on, here's a bunch of data, do some explanation. Please have an intention, but don't forget that also that needs to be executed upon. If we can find that we can do this conclusion, predict this out of the data, what do we do then? So you don't stop by being happy about it and then do nothing. So that was some takeaways to give you. I hope they will be interesting. So now let's see something practical.
All right. So I really like those handheld microphones, make me feel like a rock star. If I move it too far away so you don't hear me, please raise your hand. Because now we're getting into the really interesting stuff, and I might get a bit excited here. So I'm going to talk about the project that we've done with Västtrafik. And first, I think it's important to mention that I cannot take all the credit for this project, even not most of it. Most of it has been handled by Västtrafik. And I have only had to do the fun stuff, the artificial intelligence part. So this is a project about the To-Go app, some features in that. But let's take it from the beginning. When Corona hit and restrictions got here, this affected public transport. I put a very mysterious arrow here, and you will soon see what it's for. And you might even guess when I do this show. So here is data from Västtrafik. So this is another data set. It's not the Telia data, but it's a separate data set that we got, or that Västtrafik are continuous collecting. And as you can see, the travels varies a bit over the month. This is 2018 and 2019, and the beginning of 2020. We travel a bit less during the summers, usually. And even between different months, there are some different variations. But it's kind of stable. If you look really deep, you can see it's increasing very slightly, but not that much. But then something happened. The COVID-19 hit, and suddenly the traveling was down with 30%. And this is even more than we saw on the Telia data, where we looked at the movement has reduced by 20%. And that is also quite naturally, probably because people were avoiding public transport. And that is in itself a good thing, because people were asked to do that. That you should only travel public transport if it was absolutely necessary. And then you might think, okay, so people travel less, then it should be easy to operate, because you already have the capacity to do even more passengers. The problem is that this, of course, turned into a really complex problem for Västtrafik. Because at the same time as people were traveling less, there was also a big pressure to not, for example, reduce the number of buses, or reduce the number of possibilities for people to travel, because you don't want people to be crowded. And they also had an initial problem here that the restrictions and recommendations was updated several times. So there was new restrictions, new regulations, and every time that happened, the traveling shifted in some way or another. And as I said, it's a very complex problem, and there's a lot of different parts of the solutions here on how to tackle this. I will talk about one of the parts, and I will take the customer travel perspective. So when you travel with Västtrafik, sometimes you have a choice. You can choose to travel another time. You can choose to take another bus. Sometimes you don't, because you really need to be at that place at that time. But we want to help those that have a choice. And we want to help people to make informed choices. And this is a very busy slide, but don't worry, I will walk you through it. So here we had the first validate problem. We knew that crowded spaces led to virus transmissions. This was not Västtrafik's conclusion, but conclusions from all over the world. That is a fact. Then the idea was, okay, so can we predict how many people will be traveling? Because if we could do that, then we might have something that we can use. We had this hypothesis that if we could predict that, then we could tell people about it. Maybe that would actually help people make these informed choices. So then we started with the exploratory analysis to see what can be done here. And I will come back a bit to that, what kind of data we had. We tried to identify and validate this problem, that people couldn't know if it's going to be crowded or not. We tested it out, and we validated especially the predictive model, because if that didn't work, we could, of course, tell people to do things, but if it wasn't good enough that it actually predicted the reality, it would be bad advice. And then we need to get people to start using it, because before it's being used, there's not really that much value in this passenger perspective. There can be a lot of value in other departments on how to do this bus and things like that. But remember, now we're talking about the customer or the traveler's perspective. And how do we do all that? Well, not surprisingly, this ties into the other things that we'll talk about. To manage this, we need to keep it simple. We need to make it really easy for people to get data that they understand and that they can act on. So we want to inform people. We don't want to have this on some other level. We want to make people informed so they can do their own choices. And we want to do this because Västtrafik, of course, as everyone here, wanted to help prevent the spreading of COVID-19. So in a sense, this turned from a sort of local problem about how to do our buses, how to make people travel as much as possible, be it public transport, to a new problem that was how to make people travel as safe as possible. To do that, it all starts with the data. And here was mentioned before, Västtrafik actually has really good data on how many people are on the buses and trams and trains. The way they do this is that in all the exits and entrance of the buses, there are these infrared sensors. And it's a pair of them, meaning that they can see if people are moving onto the bus or off the bus. And also how many people are doing that. It's called APC-data, or automated passenger data collection. And it's important, because when you have that, then you actually have the data to build this prediction on. You know how many people have been on these buses. If you're just using, for example, how many stamp their cards on the bus, you would get some data, but it wouldn't be as good because you will miss a lot of the commuters that buy a monthly card and then just travel. But this data I showed before is actually, for over 95% is collected automatically. This is actually quite unique to Västtrafik. To this extent, for example, in Stockholm or Skåne, they don't have this. They're using other methods to try to figure out how many people are on the buses. Here, Västtrafik, in a very early phase, thought this was a good idea. And now I think for all the new agreement to subcontractors, it's a part of that they need to have these infrared sensors on the buses. And then you ask yourself, okay, but are they good? What happens if two people move on at the same time? What happens if I bring a bag with me? Will it register correct or not? And in many of these cases, it's really hard to figure out what is the quality of my data. Here we have a very good quality. And I can say that because I know we have that. And I know that because when the bus starts in the morning, we know that it's empty, or hopefully a driver, but otherwise empty. When the bus comes back in the evening, we also know it's empty. That means that if we'd register as many people going onto the bus and going off the bus, we'd also, using that data, see that the bus is empty. If it's not, we know that there is some problem. We know that the data is not of good quality. But if it is, then we know that it's good quality. And even if those few cases where we have a difference, so if we know it was empty from the beginning and the start, then we can use that sort of trick to normalize the data during the day to see, okay, here we must have missed one. So then we have the data, and we come into building a prediction model. And there's a lot of data that you can have, because there's a lot of transportation data going around there. Here I just listed a few of the things that we automatically collected and sort of sorted out in different ways. And I will go a little bit deep into 5 of these, both because they were actually showed that this was the most important data in the predictive model, but also because they are, compared to some of these, quite easy to understand. So one thing that we're going to predict how many people are going to be on the bus or the tram is what line number is it. The tram number 1 and number 8 has different kind of travel patterns. And the same, for example, for bus 60 or for a bus going from Vänersborg. Then we also need to know, okay, so where are we? The stop area, or the hållplats. That also have very different patterns, and it's an important data point here. As you most might have guessed, the start time of the trip might be the sort of, if you're only going to take one general thing, that is the most important thing. People travel much more between 7 and 9 in the morning, and between 2 and 5 in the afternoon. Also, these times are much less travel. Weekday, what day is it? Also very important for the model. Because even if you could see that travel on the weekends and the weekdays, for example, went down equally much, we still travel less on the weekends for one thing, but we'll travel at different times. There's not as much travel, for example, in 6 a.m. Saturday morning as it is on the Tuesday morning. And the final one here is the stop route variant. That's a bit more complicated, but it's basically what route did this bus take. And it's a bit of a fancy way to say what direction did they go. They go into town or out of town. And also even some of the more complicated lines could be if we skip some stops or not. Like that. So we have all this data. We have identified some good features. We also know historically when it was crowded or not, how many people traveled. And then we just need to build the model. Unfortunately, it's still not that easy. There are lots of other questions to building a model. The first and most important one, I guess, would be which model should we use? And to get slightly technical, there's a lot of different modules that you can use more or less out of the box. You can say import package and then start using it. But even so, it's probably not going to give you very good results unless you answer a lot of other questions. One is which data should we use for training? I think I had access to data at least from 2016 and upward, but it makes sense to use the data from 2016 to try to predict how people are going to travel now. Probably not. But then, when do you draw the line? What we end up doing for the prediction model that is in production right now is that we're using data from November 2020 and onwards, because that was after the corona restrictions set in and people are starting to change the pattern. Then, of course, we also need to select which data features we're going to use. And the tricky part is that all these are interconnected. If I switch model, I probably want to have different features as well, because different models handle this in better or worse ways. And finally, you need to configure the model. And then when you dig down to this, you get into really interesting stuff and gets really deep. And then it's really important to not forget this most important question. Why are we doing this? What are we aiming to do here? Okay, so if I get this really good predictive model, what is it going to predict? Is it going to predict the exact number of people on the bus? Is that the important thing? Probably not. So if we go back to, okay, why are we doing this? We want to help people make informed choices. We want to tell them, we give them a warning that this trip that you plan tomorrow will probably be crowded. Maybe you can choose another one. So this is actually a screenshot from my phone. This is the To-Go app. And here we can see the result of all this modeling and data that we had talked about before. It's a quite complex analysis, but what it boils down to is this 1, 2, 3 persons graphic in the app when you search your trip. There's a little text there also saying what it means, if it's crowded or usually not crowded. But essentially, we figured out that the easiest way to convey this, and the most important thing is to convey, okay, this is going to be crowded or not crowded. And the hope then when you see this is that some people that make this search will see, okay, for example, in the first example, bus 60 at this time point, going there is probably crowded. But tram 1 is not as crowded. So maybe I should choose that tram instead. Or in the other case, when you even have a trip to tram 4 that is usually not crowded at that time. Or if you sit the evening before and you decide, okay, so when should I go in shopping? And you can see, okay, if I travel at 8 o'clock, everything is crowded. But if I wait until 9:30, that might be some other options that are good for me. And then when you do these things, and especially with this corona thing, when it's happened, there was a lot of pressure to get this out now. Because if we do a really good analysis and come up with a really good model, and we put it into effect 2023, hopefully the corona is not affecting us as much, and it wouldn't have that much value. We need to have this as soon as possible. And that can be done when we had this clear purpose. We had all the data, we built a model, and we got it into action. So this app has, or the predictive model in the app, has been going on for quite a while. And then we have this little question in this case, so did it work? And one might look at this is, yes, it worked. You can see it here in the app that it worked. But another point, a piece that I think many feel they are missing is, okay, so, but how good is it? Can I trust these numbers? And it turns out that in many cases you can do that. So in this graph, you can see the green one is where the predictive model makes a correct prediction. And then on top here, we have the really small red area. And that is the missed warnings. That is when a trip turned out to be crowded, but it wasn't predicted to be crowded. And that is the really bad area that we want to avoid. Because as I mentioned, we want to help people make informed choices to avoid these trips. And if we didn't warn it, then there was no way for them to avoid it. But there is another yellow area here. And that is the opposite. So that is when we warned, but it wasn't crowded. And that is much bigger. And I think there's 2 reasons for that. One is because that is how we tune the model. We wanted to not miss any warnings at all, hopefully. To really tune it to try to not be sort of over lenient. We want to really find all these cases where it's crowded. But there is another thing here that is, could have been happening. It could actually be that it works, and it works really good. Because what will happen then is that if we predict something will be crowded, and some of the people that are going to take that trip actually decide, okay, no, I will take another trip. Then in reality, it will not be crowded. And we will have actually got an effect where we wanted. But we will look in this graph that it was a bad prediction. Because those people took that decision to not travel there, in the end it wasn't crowded. But then that would be a good thing. So we are not as worried about this yellow area here. What we really don't minimize is the red one. So my conclusion, although I'm a bit biased, is that it did work. And is it perfect? No. And we are going to a bit more later on how to improve this. But it is there and it brings value. So what if everyone used it? Well, as I mentioned earlier, then we will have no crowded trips, because everyone would avoid that. We would also have pretty bad predictions. Because whenever we want for something, no one will travel there, and it will be a completely empty bus. We are not that worried that it will happen. Several reasons. One is that many people actually can't choose. They need to go at that time, or it will be too inconvenient to take another time. But there are some people here that we want to affect. And if we affect enough people, then we will actually get the full value, because we will still not get any crowded buses. So do people use it? We don't really know. There is actually a customer survey going on at Västtrafik right now. And in that survey, they do it every year. But this year, they included more questions about this topic. Are people seeing it? Well, we know actually that people are seeing it, because it's quite hard to not see it. If you open that app, you have seen it. Are people liking it? We actually have some early answers here, and with some part of this survey is done already. We know that, yeah, there are quite a few people that like this. They want to have this information. Do they use it? Some do. Again, the survey will give us more results, but the early indication is that there's not that many that use it. But I don't think that's necessarily a bad thing. We only need enough people to use it to get value here. And even if it was just a few people using it, even if it's just much people that sort of most worried about getting infection using it, that will still brought a lot of value to these people. In some cases, I think it even might be hard to tell if they know that they've been using it or not. Because we have this nudging effect that you search your trip and you see this. Maybe you're not even that aware that you actually chose the one that was not crowded. Because some part of you felt, okay, maybe I can do that. And now we have the same slide again, but with some drop-downs. But I will skip that. So before we have these survey results, we don't really have a good definitive answer, but I think there are a lot of indications that these are already bringing a lot of value. So my apologies for getting a bit over time here, but we had some technical issues in the beginning, so that's why. I hope no one is asleep. No, it's good. Or I don't know if people on the internet, but not anyone here anyway. So what is the future of this? Well, I think it's quite fair to say this here to stay. We have seen enough people like it and see it. That is, even if this survey come up to it that it's not that many people that's using it, I think it's very likely that there's enough people using it that it should be worth keeping this going. But it probably needs to change. One important question is, what does crowded mean if we get into a post-corona setting or a new normal? Right now we have a very restrictive definition of crowded. I think for the city buses, I think the restriction was that if more than half of the seats are taken, it's called crowded. And of course, in a sort of a normal world, you probably wouldn't consider it crowded. You would consider half-empty bus pretty empty. But where to draw that line? Should it be if everyone gets a seat? Many of the buses also have standing places. And again, I hope this survey can help, that we can get some feeling of what people think of crowded. Because again, in this part of Västtrafik, we're only looking at the customer perspective here. A lot of other parts are looking at lots of other things, but in here, the most important thing is actually what people think. Do they feel this is crowded? Is this something that they want to be warned about? Could we use this in more places in the app? With some ideas, we're using it, for example, at stop areas, the hållplats signs, where you can see that. We can also bring in real-time data, and that's a bit tricky because then you really need to have a combination of real-time data and not the external data, but the predictive model. Because even if you see that the bus is empty when it starts, you can know from the predictive model that when it gets to the station, it probably will be crowded. We could connect some external data sources. Right now we have sort of only, but it's actually quite a lot of data, using this automatic passenger data that Västtrafik collects themselves. But we know, for example, from other studies or more scientific studies that the weather is something that affects people traveling. And a bit intuitive is this that if it's really raining, people travel more on really short trips because they don't like walking in the rain. But also actually, if it's really raining, people travel less on the long trips. Probably because they then take the car instead of going to the bus stop in the rain. And also, even if I show that the results on the predictive model is really good, we are far from perfect. And there's a lot of work that can be going on to get there. But I think this is a really good example of this journey that we're talking about. That we have this purpose, and we got it in action. We got these warnings into the app, and that is where we created value. And then we can improve it, and we can create more value. But if we would have waited until we had the perfect solution, we probably wouldn't have gotten a solution. So I think this ties it in, everything that we're talking about here. That it's important to have this purpose when you do data analysis. You need to know why you're doing this, and where you're going to get with it. And then you need to do it, and it can be really complicated, but then you need to make it simple, so that you can communicate it in an understandable way. And that is where you're creating value.
So thank you. This is the last slide now. Thank you for taking the time to listen, and I really hope that this will bring something valuable to you on your journeys. And a huge thank you to Telia and to Västtrafik for Telia lending us our data and Västtrafik allowing us to share this case. A really big thank you. And finally, I would also like to say thanks to our colleagues that also have been working with this, that is not here today. So thank you, everyone. Really appreciate your attention. Great. Thank you.